In this video, we are going to talk about area of compound figures. You're going to want to have your formula sheet near you to start off with, and then we're going to transition into the notes. So to start off with, you're going to go ahead and draw your compound figure onto your formula sheet. So a compound figure is basically two or more shapes that are combined together to form one shape. In this case, our compound figure is made up of a triangle and a rectangle. You'll notice that they are completely bound together, okay? Now, the formula for compound shapes is the sum of the areas of the shape. What that means is that in this case over here, you're going to find the area of the triangle as you normally would. You're going to find the area of the rectangle as you normally would, and then you're going to add those two areas together in order to get your final answer. Over here we have an example. Now remember, if I'm going too fast, you can always pause the video so that you can write down all of the examples. So over here in this example, we have a square, and then we have a parallelogram that is turned so that it's vertical. So first we're going to find the area of a square. So the area of a square is area equals base times height. So area equals, so the base of the square is 4, and the height of the square is also 4. And so 4 times 4 is going to be 16. So the area of the square is 16 yards squared. Okay? Now we're going to move on to the parallelogram right here. So the formula for area of a parallelogram is also area equals base times height. So area equals, the base of the parallelogram is 4. The height of the parallelogram is 2. So 4 times 2 is 8. So the area of the parallelogram is 8 yards squared. Now, the total area of this compound figure is going to be 16 yards squared plus 8 yards squared. So 16 plus 8 is 24 yards squared. And that is going to be your final answer. So let's go ahead and do our first example. So here we have a compound figure. It's made up of a triangle on the top and a square on the bottom. It does not matter what you find the area of first. The first thing I'm going to do is find the area of the square. So the area of the square is area equals base times height. Area equals, the base is 2 and the height is 2. So area equals 2 times 2 is 4. So the area of the square is 4 inches squared. Okay? Next, I'm going to find the area of the triangle. So the formula for area of a triangle is area equals base times height times 0.5. So area equals, the base of this triangle right here is the same length as this right here, which is 2 inches. The height of the triangle is 1 inch times 0.5. When you multiply all of that together, you're going to get an area of 1. So that's 1 inch to the second power. When you add those two together, 4 plus 1, you're going to get 5 inches to the second power, which is going to be your final answer. All right, next example. So here we have an area of 2 rectangles that are bound together. So the first rectangle that I'm going to do is the vertical rectangle, okay? So area equals base times height. Area equals, so the base of this rectangle is 1 mile, and the height of this rectangle is 5 miles. So area equals 5 times 1 is 5. So the area of this is 5 miles. Now, I'm now going to work with the rectangle that's more horizontal. Same formula though. Area equals base times height. Area equals. Now, here's where we have to be really careful. This says 6 miles, but 6 miles is the length of this entire base, which includes this part right here. This is not part of this rectangle, so we need to take this part out of it. How do we do that? Well, we know that this is the same length as this, which is 1 mile. So we need to subtract 1 mile from this. So 6 minus 1 is 5. So the base of this rectangle is 5 miles. And then the height of this rectangle is 2 miles. So area equals 5 times 2 is 10. Now we need to add up the two areas. So 5 miles, oops, I'm sorry, I forgot my squared on both of these. 5 miles squared plus 10 miles squared is going to be 15 miles squared as your final answer. All right, next example. So here we have a rectangle and a triangle combined together. So first I'm going to find the area of the rectangle. So we have area equals base times height. Area equals, so it gives me the base is 110, and it's very specific. It shows me that it goes from here to here, which is exactly what I wanted. I needed it to end right here because this is where the triangle starts. And then the height of the rectangle is 140. So area equals 110 times 140 is 15,400. Centimeters squared. Now we're going to look at the triangle. So that's going to be area equals base times height times 0.5. And so we're going to find the area of the triangle. So the base of the triangle is 70 centimeters, and that's from here to here. The height of the triangle is 90 centimeters. And it's very specific. It gives me the height, because then it also says that this is an extra 50 times 0.5. So when I do 70 times 50 times 0.5, I get 1,750. Oops. Now, I'm going to add those two together to get my total area, which is going to be 17,150 centimeters squared. All right, next example. So here we have a coordinate plane, and it's going to be the same thing. So we have two shapes here, and we can separate these a lot of different ways. So one important thing to know is that with compound figures, there are several ways that we can separate it. No matter how you separate them, you should get the same answer as long as you calculate it correctly. So for example, I could separate this right here, and this would be one shape, and this would be one shape, and I could add them together and get one answer. Or I could choose to separate it this way, and I would have a rectangle here and a rectangle here, and I should add them up and get the same answer. It doesn't matter how you do it, you should get the same answer no matter what. Okay? So I'm actually going to choose to separate it like this, but you can choose to separate it any way that you would like. Okay? So I'm going to choose to separate it into two rectangles. So I have more of a thicker rectangle, and then I'll work with the thicker rectangle first. Okay? So my thicker rectangle has a base of 1, 2, 3, and a height of 1, 2, 3, 4. So area equals base times height. Area equals 3 times 4. Area equals 12. So that's going to be 12 units squared. Now I'm going to work with this rectangle. So this rectangle has a base of 2, and it has a height of 1, 2, 3, 4, 6. So area equals base times height. Area equals 2 times 6. Area equals 12. So this thinner rectangle also has an area of 12 units squared. When I add 12 units squared and 12 units squared together, I'm going to get 24 units squared. And that's going to be my final answer. All right, you go ahead and try this one, and then we will compare answers. All right, go ahead and pause the video if you're not done. So, when you found the area of rectangle A, you should have done 10 times 2, which is 20 centimeters squared. Rectangle B is going to be 4 times 7 centimeters, which is 28 centimeters squared, which is going to give you a total of 48 centimeters squared. Okay, next one. Go ahead and try this one. All right, go ahead and pause the video if you're not done. So for this one might have been a little trickier because you had to determine how you're going to separate the shape. And you could have chose to separate it a couple different ways. I chose to separate it to make the top a triangle and the bottom a rectangle. So when I made the top a triangle, I had area equals base times height times 0.5. So the base of this triangle here is the same length as this right here, which is 21. The height of the rectangle, we didn't really know. Well, the height of the entire shape is 32. The height of this right here is 16. So we needed to find the height of the triangle. 32 minus 16 is 16. So the height of the triangle was 16 times 0.5. So that gave me an area of 168 centimeters squared. Then the rectangle was a lot easier. 21 times 16, which was 336. When I added them together, I got 504 centimeters squared. All right, go ahead and try this one. All right, so go ahead and pause if you're not done. So for the first one and for the second one, these were both trapezoids, okay? So you had to use the trapezoid formula for both of them. And I labeled them 1 and 2 to make it a little easier. The base for the first trapezoid was 12 and 20, and the height was 6, and you should have gotten 96 centimeters squared. For the second trapezoid, there was a base of 10 and 20. They shared that second base here down the middle. The height was also 6, and you should have gotten an area of 90 centimeters squared. And then the total area was 186 centimeters squared. All right, we're going to try some word problems now. And these are also going to be some of them on the coordinate plane. So Annika is hiking a trail at a national park. She starts at point -22 and she hikes 4 units east. Then she hikes to point 20. From there she hikes 4 units west. She stops for a break and then she hikes to the point 0-4. From there she goes back to 02. What is the total area Annika covered? Okay, so let's start where she starts. She starts at the point -2, 2. So -2, 2. And she hikes 4 units east. So remember our compass rose from social studies. North, south, east, west. Okay? So she hikes 1, 2, 3, 4. Okay? Then she hikes to the point 20. So 20 is right here. So she goes down here. From there, she hikes 4 units west. So now we're going to go west, which means we're going to go to the left. 4 units. 1, 2, 3, 4. Right here. She stops for a break, and then she hikes to the point 0-4. So 0-4. So down here. What is the total area Annika covered? So now what we need to do is go ahead and connect the dots. All right. Now, we can again separate this into several different shapes. My gut instinct tells me to separate it like this, so that we have a rectangle up here and a triangle down here. And so that's how I'm going to solve it. So first I'm going to find the area of a rectangle. So area equals base times height. Area equals, so the base is 1, 2, 3, 4. And the height is 1 and 2. So 4 times 2 is 8. So this is 8 units squared. Alright, next I'm going to find the area of the triangle, which is area equals base times height times 0.5. So first I need to find the base. So the base of the triangle is here. 1, 2, 3, 4. Now I need to find the height of the triangle. Remember that height is not slanted, it's up and down. So 1, 2, 3, 4 times 0.5. When you multiply all of those together, you're going to also get 8 units. Squared. 8 units squared plus 8 units squared is 16 units squared. All right, next example. Miss Robinson's new pool shed door is made up of a rectangle that has a length of 8 feet and a height of 12 feet and a triangle that has a height of 3 feet and a base of 8 feet. What is the area of Mrs. Robinson's new door? So here's the shape, but we need to label it with the directions and then find the area. So it has a rectangle that has a length of 8 feet and a height of 12 feet. So the height is 12 feet and the length is 8 feet. And then the triangle has a height of 3 feet and a base of 8 feet. So we need to find the area. So I'm going to find the area of the triangle first. So area equals base times height times 0.5. Area equals, so the base of the triangle is 8 feet. The height of the triangle is 3 feet times 0.5. When you multiply all that together, you're going to get 12 feet to the second power. Next, I'm going to find the area of the rectangle, which is area equals base times height. The base of the rectangle is 8, and the height of the rectangle is 12. And when you do 12 times 8, you're going to get 96. And that's going to be the rectangle, and that's 96 feet squared. And when you do 96 and you add the 12 to it, you're going to get 108 feet to the second power. And that's going to be the total area of the door. All right, next example. AGMS is building a new brick wall in front of the school. The wall is made up of one rectangle and one square. The rectangle has a length of 144 feet and a height of 4 feet. The square has the same height. What is the area of the wall? Okay, so the rectangle has a length of 144 feet. So from here to here is 144 feet, and it has a height of 4 feet. The square has the same height, 4 feet. And the thing that we know about squares is that all the sides are the same, so that we also know that the base of the square is also 4 feet. So it wants to know the area, so I'm going to go ahead and calculate the rectangle first. So area equals base times height. Area equals 144 times 4, which is 576 feet squared. And then I'm going to calculate the square, which is area equals base times height. And both of those are going to be 4. So the area is going to be 16 feet squared. And when I add both of those together, I get 592 feet to the second power. All right, next example. The bases of a trapezoid are 4 inches and 10 inches. The height is 3 inches. The base of a triangle attached to the trapezoid is 8 inches. The triangle shares the same height as the trapezoid. What is the total area? So don't let this be overwhelming to you. We just have to take it one step at a time. So the bases of a trapezoid are 4 inches and 10 inches. So here's your trapezoid. So the 4 inches is going to be the shorter base. So this is 4 inches. And then this is 10 inches. The height is 3 inches. Okay. The base of the triangle is 8 inches. So this whole thing right here is 8 inches. The triangle shares the same height as the trapezoid. So the height of the trapezoid was 3 inches. So the height of the triangle is also 3 inches. Now let's go ahead and calculate the area. So I'm going to do the area of the trapezoid first. So area equals base 1 plus base 2 times the height times 0.5. area equals, so base 1 is 4 plus base 2 is 10. The height is 3 times 0.5. Area equals 4 plus 10 is 14. Bring down the rest of the problem. And when I multiply all of that together, I'm going to get 21 inches squared. Now I'm going to calculate the triangle. So area equals base times height times 0.5. Area equals, so the base is 8, the height is 3 times 0.5. Area equals 12. And so that's going to be 12 inches squared. When I add those two together, I'm going to get 33 inches to the second power. All right, you go ahead and try this one. The backdrop for the spring, oh, sorry, you try. I don't try it for you. You try, sorry. Alright, go ahead and hit pause if you're not done. So, for this one, we have a rectangle bottom that's 55 feet with a base and 30 feet high, which will give you 1,650 feet squared. And we have a triangle top that has a base of 55 and a height of 10. So 55 times 10 times 0.5 is 275 feet squared. When you add both of those together, you should get 1,925 feet squared. All right, go ahead and try another one. Alright, go ahead and hit pause if you're not done yet. So, one thing I want to say is that you can interpret these drawings any way that you want, because ultimately it doesn't matter how the shapes fit together, you're going to find the area with the given dimensions. So it doesn't matter if you drew the rectangles on top of each other or in a different order. As long as you use the proper dimensions, everything is going to work out okay. So as long as you used 5 inches and 5 inches for the base and height of the square, you should have gotten 25 inches squared. And as long as you used the dimensions of 9 inches by 10 inches for both of the rectangles, you would have gotten 90 inches squared. Now, you want to make sure that you have 90 inches squared because there were 2 rectangles. When you added up 90, 90, and 25, you should have gotten 205 inches squared. All right, last you try. Alright, go ahead and hit pause if you're not done. So, here's the drawing that this described. Notice that the parallelogram, it does share a base with the square. That's why this is 18, this is 18, and this is 18. So the area of the parallelogram was base times height, which is 18 times 13, which would give you 234. The area of the square was 18 times 18, which would give you 324. And when you added those two together, you should have gotten 558 centimeters squared. Alright, that is the end of this video. It was a little long, but you should be a pro now at compound figures.